Okay, so we're still talking about separation of variables. It always requires a multiply and or divide process. So we're always multiplying by dx. And then to move the y terms depends. Sometimes it's a multiply, sometimes it's a divide, depending upon what you have in that derivative expression. Sometimes it's just a y to a power. Sometimes you're moving a whole group, like a 2y plus 7. You know, you have to bring it over as a group. Today's notes focus was on natural log and antiderivatives that lead to exponential functions. So we've got to get comfortable with when we have ln(y) equals x squared plus, I'll say c. At that point, we put in our initial condition and find a value that this needs exponentiation in order to get the y to be solved for. And so this is an absolute value. This means just y equals, because e to the ln is an identity that brings the y down in front. And then this is e to the x squared times e to the c. That's our property of powers. If we have x squared plus c in the power, that we can, since it's the same base, we can give each power its very own base. And e to a constant is just a number. So what they do is they generically call e to a constant, they just call it c. I know we're using c a couple of times and it means a different thing each time, but this is just c times e to the x squared. And they bring the constant out front. And if I gap here for a reason, because we're talking about natural log and because we're talking about the absolute value of y, we really have a plus or a minus out in front of that solution. It's almost like square rooting something. It's because of the absolute value. We can have a plus or a minus inside there. And what determines whether we choose the plus or the minus is where our initial condition stands. If we have an initial condition that has a plus y, then we pick the plus solution. If we have an initial condition that had a minus y picked, then we pick the minus solution. Okay. So just kind of a little insight into that as you work with it. Come on, trying to find my, there we go, there's my cursor. Okay, so I kind of went over what does the integrand need to look like for a natural log antiderivative to be needed, right? If we have a natural log antiderivative, we have a 1 over y or a 1 over 2y plus 7 or something like that. On the dx side, we'd need like a 1 over x, so that sort of thing. So your knowledge of exponentials, we're going to have to dust off that knowledge. That's important. It's kind of like a unit circle values. Those are kind of two important things. Okay. So oh yeah, natural log antiderivatives, right? We need a natural log on the dy side. We need a 1 over y on the dy side. If we had a natural log on both sides, we could actually just get rid of the natural log altogether. And of course, neither side is, everything's out of the picture anyway. Okay, so unit 7, day 7 topic questions are free response questions. Let me just verify that. Yep, they're free response questions. In other words, they are not, there are no topic questions. We need to dig into these free response questions. These are super important. So you'll do that after the quizzes. So if you notice this question A, I have you pick a problem. So You can choose either one. I don't care which one you choose. It was just a way for me to give you another set of practice. Like if you chose one, if you chose, you know, the one in the blue, then stick with that expression for all the parts for B, C, and D as well. So if you choose the blue, then you're choosing to circle quadrant 3 in part B, and then the first solution in part C, and then the first solution in part D. So you're kind of like, if I'm going with this first one, I'm going with my first choice in each one of the parts. If I'm going with my second one, then I'm going with my second choice in each part. It's just a way for me to give you like 2 questions. And that way you've got something to go back to if you want to work on that question. A different question, but the same type of solution. Okay, so you're going to go ahead and take the quiz. I don't think it's really 12 minutes. I think it might be 8 minutes. I think it's a 4-question quiz. And then after you're done with the quiz, hit these free response questions. I know I've given you a couple of free response questions as topic questions. I'm hoping you're working on those. I haven't been looking at those too closely, but I'll look at these closely. These are exponential. So this is where you're going to get that comfort level with exponential solutions.